Okay, hello guys. What we're gonna do today is explore Binomial's theorem and Pascal's triangle. So firstly, I think we all know what a plus b squared is. Like if it expanded, it will be a squared plus 2ab plus b squared, right? And what is a plus b to the third power? It is a cubed plus 3a squared b plus 3ab squared plus b cubed. But these are all the things that we memorized, we kind of know. But what if we do a plus b to the power of n? How to expand it? Like what is the formula or what's the mechanism behind all of these? How do we know that the coefficients is 1, 2, 1, 1, 3, 3, 1, and etc.? So we're gonna approach this with a combination and permutation point of view and how it explains the coefficients and also the power. Okay, now let's do an example of a plus b cubed. Right? What does a plus b cubed mean? It means a plus b multiplied by themselves 3 times. Right? So let's think of a parenthesis as a person. So we have 3 people. Each holds a and b on their left and right hand. And what other possibilities there? There are possibilities where there are 3 a's multiply each other. Let's say a cubed. There's also a possibility where there's 2 a's and 1 b. There's also a possibility where there is 1 a, 2 b's. And finally, 3 b's. Right? Now, we can also rewrite a cubed as a cubed times b to the power of 0. Sorry, b to the power of 0. And b cubed as a to the power of 0 times b cubed. Because anything, as we all know, anything to the power of 0 is 1. Okay. And now let's look at from b's point of view. In the first term, this means that out of the 3 people, none of them gave out b, right? So this means out of the 3 people, so from the 3 people, none of them chose b, or none of them gave out b. And in the second example where it's a squared b, out of the 3 people, one of them gave b out. So it could be either person A or person 1, person 2, or person 3. Either one of them gave out 1b, right? And if you give out 1b, meaning that the other 2 gave a. So it makes sense here. So what about the third one? So from what we know, this means that there are 2 b's. So out of the 3 people, 2 of them gave out b. And the last one, out of the 3 people, 3 of them gave out b. So the front are the number of possibilities, right? So that's how we get equals to plus plus plus. This is how we got a cubed plus 3a squared b plus 3ab squared plus b cubed, right? Because this is 1, this is 3, this is 3, this is 1. 1, 3, 3, 1. Right? Okay. So now that we understand this is like the number of powers, it's like the number of people, and each of them consists of an a and a b, a left hand and a right hand, and it depends on what alphabet or what things each one of them put out. So let's say I have a plus b to the power of n, indicating that there are n people. So let's draw n people. 1, 2, n people. And each holds an a and a b. Right? So the possibilities are where a to the power of n and b, no one chose b, or n minus 1, one of them gave out b, n minus 2, two of them gave out b, dot dot dot, until all of them gave out b, right? So let's look at the coefficients then. Out of the n people, none of them gave b. Out of the n people, one of them gave b. Out of the n people, two of them gave b. Plus dot dot dot, out of the n people, all of them gave b. So this is the formula of the coefficients and also the, what's that called? The powers of a and b, where a plus b to the power of n. Now this is called Binomial's theorem, where from this we can expand it into different terms, like the simplest different terms, basically. So in the middle, let's say c and choose k, like in the coefficients, then what would be the power of a and b? Well, from here we know that we chose k of b out, so it will be b to the power of k, and since there are n people, so it will be a to the power of n minus k, right? Okay, now let's give an example. Let's say a plus b to the power of 4. So we can do the conventional way where we multiply everything out and write down everything, or we can use Binomial's theorem. From the 4 people, none of them gave b, so 4 of them gave a. Plus from the 4 people, 1 of them gave b, and 3 of them gave a. Plus c4 choose 2, a power of 2, b to the power of 2, plus c4 choose 3, a1, b3, plus c4 choose 4, a0, b4, right? And then the coefficients will be, well, this is 1, so a to the power of 4, plus this is 4, a third b, plus this will be 6, a squared b squared, plus 4ab cubed, plus b4. And actually, if you multiply this by 4 times, you'll get this expression, right? So again, from the either way, from algebraically point of view or from the combination point of view, they all reach the same goal. They all reach the same conclusion, right? And what is the mechanism? Well, what is Pascal's triangle? It's basically similar things. So Pascal's triangle, it's where you put 1 on either side, and then the middle part will be the combination of the top 2. So let's say it will be 2, so it will be 1 to 1, and this spot will be 1 plus 2 equals 3, 2 plus 1 is 3. Here it will be 1 plus 3 is 4, 3 plus 3 is 6, and then 1 plus 3 is 4. And if you continue, you can reach different numbers. Well, this seems familiar. 1 to 1 is a plus b squared, like the coefficients, because 1a squared plus 2ab plus b squared, right? And 1, 3, 3, 1 is basically 1 plus b to the power of 3, and it will be a to the power of 3 plus 3a squared b plus 3ab squared plus b cubed. And this is the thing that we just got from the binomial theorem. A plus b 4, it will be a to the 4 plus 4 blah 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 6 4 1. I'm not gonna continue. So this is actually a cool phenomenon where initially we have different approaches, but we got the same value, we got the same thing that we wanted. That's the beauty of math. Like, either way, all roads lead to Rome. Either way we approach it, if it's logical and it's reasonable, it always reaches the same like the same conclusion. Like yeah, wherever we approach this algebraically, or from a combinations point of view, or from a weird not weird, but from a pattern that we observed, they all reach the same thing. That's what astonished me when I first came upon this theorem. Well, in the next few videos, I'll be given some examples to how to do questions regarding binomial theorem, or binomial theorem. See you then. Bye bye.